Ultraviolet light, UV, is a type of electromagnetic radiation that is characterized by its wavelength, which ranges from approximately 100 to 400 nanometers. UV radiation is present in sunlight, and it can also be generated artificially. Various sources such as lamps and lasers. From a physics perspective, the mechanism of UV light involves the interaction of photons with atoms and molecules, which can lead to a range of physical and chemical effects. In this video, we will explore the mechanism of UV light in detail, including its properties, sources, interactions with matter. Here are some basics. Of radiation is classified into three categories based on its wavelength: UVA, UVB, and UVC. UVA radiation has a longest wavelength, 320 to 400 nm, than UVB radiation, 280 to 320 nm, and UVC radiation, 100 to 280 nm. All three types of UV radiation are higher in frequency and energy than visible light spectrum. The energy of UV radiation is proportional to its frequency and inversely proportional to its wavelength, as described by the equation E equals hf, where E is energy, h is blanks constant, and f is frequency. The high energy of UV radiation means that it can ionize atoms and molecules by ejecting electrons from their outer shells, leading to the formation of free radicals and other reactive species. UV radiation can also cause molecular vibrations and rotations, which can induce changes in the structure and behavior of molecules. As discussed earlier, the primary source of UV radiation is the Sun, which emits a broad spectrum of radiation including UV radiation. 2. Lasers. Lasers can be used to generate UV radiation with a very narrow bandwidth, which can be useful for certain scientific and industrial applications. 3. Mercury vapor lamps. These lamps emit UVC radiation and are used in water treatment and sterilization. 4. UV-LEDs. UV-LEDs are a type of light-emitting diode that emit UV radiation in a range of wavelengths. The interaction of UV radiation with matter can lead to a range of physical and chemical effects. Some of the effects of UV radiation on matter include: 1. Photoionization. UV radiation can ionize atoms and molecules by ejecting electrons from their outer shells. This process can lead to the formation of free radicals and other reactive species, which can cause chemical reactions and damage to biological systems. 2. Excitation and de-excitation. UV radiation can excite atoms and molecules to higher energy states, which can induce chemical reactions and changes in molecular structure. When these excited atoms and molecules return to their ground state, they can emit radiation in the form of fluorescence or phosphorescence. 3. Photodissociation. UV radiation can break chemical bonds in molecules, leading to the formation of radicals and other reactive species. This process can be important for atmospheric chemistry, where UV radiation plays a key role in the breakdown of ozone and other atmospheric components. 4. Photochemistry. UV radiation can induce chemical reactions in molecules, leading to the formation of new compounds or the decomposition of existing compounds. This process is important in a range of scientific and industrial applications, including the synthesis of new materials and the degradation of pollutants. Let's talk about how it interferes with biological processes. When UV radiation is absorbed by DNA molecules, it can lead to the formation of photoproducts, such as cyclobutane, pyrimidine dimers, CPDS, and pyrimidine, 6-4, pyrimidone photoproducts, 6-4 PPS, I. No fancy name, but just keep in mind that they are abnormal chemical bonds between adjacent pyrimidine bases. These photoproducts can cause structural damage to the DNA molecule, leading to physical distortion and chemical modification. The distortion can interfere with the normal DNA replication and transcription processes, leading to genetic mutations and other forms of genetic damage. Biochemical compounds such as enzymes called photoallyase can repair the photoproducts by breaking the abnormal chemical bonds and restoring the DNA's normal structure. However, some photoproducts can be resistant to repair, leading to the accumulation of genetic damage and potentially contributing to the development of skin cancer. UV light is not that kid in your class you can joke about. In addition to DNA damage, the absorption of UV radiation by the skin can also lead to the production of reactive oxygen species, or OS, such as superoxide anion, hydrogen peroxide, and hydroxyl radicals. These OS can damage cellular membranes and proteins, leading to oxidative stress and inflammation. The body has natural antioxidant defenses, such as enzymes like superoxide dismutase and catalase, to neutralize the harmful effects of OS. However, excessive exposure to UV radiation can overwhelm these defenses, leading to cellular damage and potentially contributing to the development of skin cancer and other diseases. Anyway, that's all for today. Before that, I would like to congratulate you for having patience to watch this entire video and not get distracted by TikTok.